Hi guys and welcome. I am Math Lady T. Today we're going to be talking about parent functions. We are going to look at several parent functions. Now, what is a parent function? It's the simplest function of a family of functions with common characteristics. So this is the most simple form of this type of function. Okay, now we're going to talk about 6 different parent functions, and these are most common. We have constant, linear, absolute value, quadratic, cubic, and square root. First one we're going to talk about is the constant function. So this over here, we're going to talk about it. Now, the constant function, the equation for a constant function is f of x. It's a function, so we can write f of x is equal to, and I'm going to write the letter a. A represents any number. So it can be f of x equals 6, f of x equals -2, f of x equals 7, right? This a represents any number. So I'm going to make a graph, a sample graph where we look at a constant function. So let's say that our graph is this right here. A constant function will look like a straight line. It's a horizontal line, okay? It passes our vertical line test, so we know that it is a function, excuse me, and it is a horizontal line, okay? So all of your constant functions will be horizontal lines. Now, let's look at what this particular function is. So if I was going to write the equation for this function, I would put f of x equals whatever the value of this y is, okay? It's right here. This is our origin, and if I'm counting by 1, f of x is equal to 1. So that's the equation of this constant function. Now, let's talk about the domain and the range. Let's talk about our domain. So remember, our domain are our x values, our range is our y values. So my domain talks about how far left does it go all the way to how far right does it go. If I look at this graph, because I see these arrows, that means that it continues in that direction and it continues in this direction. So the way that I write my domain, it's going to be all real numbers because it never stops. So it's all real numbers. Now, how do I write that in interval notation? I'm going to write a parentheses, negative infinity, comma, positive infinity, and another parentheses. What that means is this line will go forever left all the way to forever right. So it's all of these numbers are included on this graph. That's the domain. Remember, domain's left to right. Now, range is up and down. If I look at this graph, if I'm going up and down, if I'm panning this going up and down, the graph is only right here. So there's only one number that this line is as far as my range, and that is 1. So y, which is my range, is just equal to a positive 1. And so that's how I would write that. All right, let's add on to our constant function. I want to talk about a couple more things with you when it comes to this. Remember, this is a horizontal line, and we're going to talk about the y-intercept and the x-intercept. Now, y-intercept means where does the graph touch your y-axis? The x-intercept is where does it touch the x-axis? Where do they intercept? So if I'm looking at the x-intercept, where does this graph touch the x-axis? Well, it doesn't. It's parallel to the x-axis. It never touches it, so there are no x-intercepts. So we have none. Now, what about the y-intercept? Where does this graph touch the y-axis? So if I'm looking at the y-axis, where does this graph touch it? It touches it right here. So your y-intercept is right here at this point. And our next parent function is the linear function. Now, look at the word linear. What word do you see within that word? We see the word line. So your linear functions are going to be your straight lines. Another way that you would see this is identity, okay? Your linear function and identity, those are the same thing. Now, the graph for the equation for this would be f of x equals x. F of x equals x. Now, our linear functions are going to look like this. And my line isn't just, it's not perfect, guys. But okay, so it's going to be a straight line. Now, let's look at this linear function. We're going to look at the domain. We're going to look at the range. We're going to look at the y-intercept and the x-intercept. Okay, so we know that the function equation, or this function rule, is f of x equals x. Now, remember, these are parent functions, so this is the most simplest form of a linear function equation, okay? Now, let's look at our domain for this particular graph. So our domain, remember, that is going to be our x values and then our range or our y values. So if I'm looking at how far left this graph goes, notice that it's going like this. And as it goes down, it's moving more to the left. Okay, it's moving more to the left as it goes down. So that means it's going to go to the left forever. Now, how about to the right? To the right, it's going to keep going up and to the right. So it's going to go to the right forever. So remember, when it goes on forever in both directions, we say that the domain is all real numbers. And I'm abbreviating for numbers. Now, in interval notation, how do I represent that? That means that it goes as far negative to forever, all the way to far positive to forever. So negative infinity all the way to positive infinity. Now let's look at the range. The range is how it moves up and down, okay? Now if I look at how low this graph is, since there's an arrow, that means it's going to continue to go low, low, low. So it's going to go forever low. Now what about high? How high will it go? Because it's an arrow, it's not like an endpoint, it's going to continue. So it's going to go forever up. So we're going to put the same thing for our range. The range is going to be all real numbers as well. And we're going to go from negative infinity to positive infinity. Now let's look at our x-intercept and our y-intercept. Now, remember, our intercepts is where it touches that axis. So if I'm talking about my x-intercept, I need to know at what point does this graph touch the x-axis. So when I'm looking at the x-axis here, it touches right here on that x-axis, right? Now, what is the ordered pair for that? X is 0, y is 0. Now, let's look at our y-intercept. Where does it touch the y-axis? It touches right here. Well, what is the ordered pair to that? It's 0, 0. So our x-intercept and our y-intercept is 0, 0. Next, we have our absolute value parent function. So absolute value. And the equation for this one looks like this. F of x equals the absolute value of x. Remember, absolute value look like two lines that are parallel to each other. So f of x equal the absolute value of x. Now, these graphs look like this. They look like a V shape. So I'm going to do my best. Again, this isn't perfect. This is just for you to get the idea of what the shape looks like. So it looks like a V. Now, let's talk about the domain and range. So our domain, remember, is how far left it goes. The range is how far up. How far left to how far right is the domain. The range is how far down to how far up. So let's look at the domain. Since it has an arrow, it continues in this direction. So it's going to go forever left and forever right. So this will be all real numbers. And then negative infinity to positive infinity. The range, how far down does it go? It goes to 0. So 0 is the lowest point, and then it goes up forever. So how do I write that? So it starts at 0, and it goes up forever. So the way that you would write that is y is going to be bigger than or equal to 0. Okay, now 0 is included because it's on that little line, and it's anything bigger than 0. It's nothing less than 0. It has to be bigger than or equal to 0. So that's how you write it as an inequality. And as interval notation, you will write a bracket, a 0, comma, infinity, parentheses. Now, what is your x-intercept and y-intercept? X-intercept, where does it touch your x-axis? It touches it right here. So that's at 0, 0. And where does it touch your y-axis? So the y-intercept is also at 0, 0. It touches the y at 0, 0. It touches the x at 0, 0. And then one thing I want you to notice about this graph is it's a V shape. So this is V-shaped. So your absolute values look like a V. Next, we have quadratic function. This is going to be f of x is equal to x squared. Again, this is our most simplest form of a quadratic function. So these graphs are going to look like this. Again, it's not perfect, but you get the point, right? So for our quadratic functions, we have f of x equals x squared. Our domain is going to be all real numbers. Of course, we're thinking about from left to right, which is negative infinity to positive infinity. Our range is going to be y is greater than or equal to 0. So just like that absolute value, this one, the lowest point is right here. And so our range is this number and anything bigger. So the way we write an interval notation, write the 0 and our infinity. Now let's look at our x-intercept and y-intercept. Where does it touch the x-axis? So our x-intercept is going to be at 0, 0. And our y-intercept also is at 0, 0. Okay? And what shape does this one have? This one has a U shape. So our quadratics are U-shaped. The absolute values are V-shapes. Now let's talk about our cubic function. So our cubic function is f of x is equal to x cubed, or x to the third power. And this graph looks like this. So with this graph, when we talk about our domain is left to right, remember? So we're going to have all real numbers, because even though it's a slight movement, it's still continuously going more and more to the left, and this is continuously going more and more to the right. So it's all real numbers, and remember, it's negative infinity to positive infinity. And our range, up and down, is the same thing, all real numbers. Now let's talk about our intercepts. Our x-intercept is going to be where it touches our x, so that's 0, 0. And the point where it touches our y for our y-intercept, that's also at 0, 0. Our last graph is the square root function. And the equation for that is going to be f of x equals the square root of x. Now this graph looks like kind of like a horizontal half of a parabola. Now we didn't talk about the word parabola, but I'm going to go back and tell you what that is. A parabola is what a quadratic function looks like. So it looks like that U shape. That's also called a parabola. So this would be a horizontal half of a parabola. So for this one, the domain is going to be left to right. So we notice that it goes 0 to infinity. So that means that x is going to be greater than or equal to 0. Now, how do you do that in interval notation? You do 0 to infinity parentheses. Now, what about your range, up and down? Same thing, y is greater than or equal to 0. So we have 0 to infinity parentheses. All right, now let's talk about the x-intercept. Where does it touch the x-axis? It touches right here, so that's at 0, 0. And the y-intercept is also at 0, 0. That is all of our parent functions. I hope you enjoyed this lesson. Please remember to like, share, and subscribe, and I'll see you next time.